So we've been talking about separation of variables, which happens to be a technique we've been using all along, but now we're just going to introduce it formally. So let's think back to implicit differentiation. What was implicit differentiation? Implicit differentiation was when we had some equation in x's and y's, and we took the derivative and then solved for dy. So we solved for dy dx, but we may have had, could be a function of x and y in the end. And so what we did was, what we're going to do is we're going to look at our differential equation now and see how we can solve that. So we might have a differential equation that's some function of x plus some function of y times dy dx, and we have to be able to do this. Now we're going to solve for y. So we have n function of y dy dx equals negative m of x. Or now I can separate this out. So this tells me that this n of the function of y times dy equals the function of x times dx. And now once I've separated it, I'm going to quite easily I can integrate it to find out what y is. I would solve for y, and then I would integrate both sides, and I would solve for y. I would get y by itself. Sort of like implicit differentiation, I would take the derivative of everything, and then I would solve for dy dx. Now here we're solving for y. And this is what we did when we did exponential growth and decay, and we've done it before. Now it's just formally introduced.